Hello. So today we've got some grid stuff to do. Hopefully reasonably, I say again, every day, reasonably straightforward. But we'll see. So what we've got here is a really, aside from the story, we've got a grid here, this sort of grid thing, and oh gosh, and it has numbers in it, which can be, I think, any number of digits. And there are symbols in it as well. We don't know what all the symbols are, but we do know that they are not digits, and they're not dots either. So our job is to find, I believe, all of the numbers that are adjacent, even diagonally, to one of these symbols. So which one is not? This one is not. This one is. This one is. This one is not. Yeah, that's our objective really. And I imagine the puzzle input is going to be bigger. Yeah, it's going to be large, but not computationally large, just larger than you could do by hand. And if we look at the symbols, they're all pretty reasonable. No sort of spaces, I think, used as a symbol. That would be funny, wouldn't it? Yeah, no spaces. Fine. Okay. So if we want to diagram this out, get a sense of what we've got to do. Now, so the first thing we've got to do is extract all the numbers, right? And I think, again, my 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 not using regexes on the first day does not necessarily mean that it is a bad idea to use regexes on the latter days, which is something I'm getting stuck on. Um, I think regexes are a decent way to do this. I'm just going to iterate through the lines and extract the numbers. I'm going to do a kind of parsing pass on it. And I'm going to extract the symbols as well, add them to add them essentially to a data structure like this. So let's say we've got a list of numbers, and the number is something like 467, and then we've got an x coordinate and a y coordinate. The x coordinate in this case is 0, and the y coordinate is 0. And then we've got a derived property, which is a width, which is going to be 3. And now I think of it, I do wonder, are we likely to have vertical numbers as well? It's not really looking like it, is it? Not that many vertical numbers here. Obviously, it's not from here, but it could be a possible path to the next step. It doesn't really look like it. Hmm. Is that a number? No, it's got to be a symbol, right? Let me check the requirements here. Hmm. Let's ignore minus numbers. Let's say they're not. These don't count. The minus the hyphen symbol is just a symbol like any other. Okay, so we've got this, and then we've got symbol. We really don't need currently to store the symbol, but I suppose we could. So we've got an x, an asterisk. Sorry, the x is. See, I've got the annoyingly. I've got the. This is an ellipsis. Very irritating. Okay. Anyway, 1, 2, 3, 4. No, sorry. This is 0. 0th character, 1th, 2th, 3th. So this is 3, and yeah, the y of course will be 1. And well, there's no width or height for symbols. Let's add another number here. Let's go with one that we know is not right, like 58. And this is going to be 0, 1, 2, 3, 4, 5, 6, 7. And the y will be 0, 1, 2, 3, 4, 5. And the width will be 2. And then the symbol here closest is the plus symbol, which is going to be x of 0, 1, 2, 3, 4, 5, 6, 7. No, 0, 1, 2, 3, 4, 5. And then the y is going to be the same. It's going to be 5. Okay, so we've got some numbers here, and we're going to ignore the others. So I'm just going to highlight these in. Oh, no. I'll just highlight these to show that we are actually putting them in. Okay. So at this point, I was thinking it through, and I was thinking there's two approaches you could take, and they're probably equivalent, really. You could take this number, for example, 467, and you could work out all of the adjacent cells to it. So you start off, I don't know, with with getting the start coordinate and going one to the left, one above. Well, in fact, probably a more efficient way of doing this, but you could just take all the adjacent characters to the 0th character, which is up left, up, right, right, right down, down, etc. And then you could work out, you could check whether any of them have a symbol in them. And if they do, then your number is good, and you can short circuit and say that number is good. And if they don't, you run through them all eventually, and at that point your number is not a part number. So that would seem to work. If you go around all these numbers, that would seem to work. Now you could do the other way around, where you go with the symbol wise. So you start with the symbol and you go round, get all the adjacent ones. Then you don't have to do this funny logic working out what's around the numbers, but in fact, you then have to do a slightly more complicated operation with the number, where you work out whether the number is covering a cell or not. But that is probably slightly simpler, because you only need to work out, is it xy, is it x plus 1y, is it x plus 2y, is it x plus 3y, and then you're fine. So actually, probably that is the better way to do. Go symbol wise. Go through all the symbols, which is probably going to be more efficient as well. Go through all the symbols, and if there's a number in the symbol, that gets added to the list of numbers that you care about and that you would then add up at the end. You then need to make sure not to short circuit, because you don't care whether the symbol has a number around it, you care all the numbers the symbol is around. So you need to count 35 here as well. Okay, so our algorithm looks roughly like this. So first we've got to parse it. So let's go back here for every line. I'm going to use a regex to extract numbers, extract symbols. Okay, and then for every symbol, find adjacent cells. Oh no, wait a minute. So if we want to find, if we want to do it this way, let me actually, I'll reach adjacent cell, go through each number. That's the number cover. Does the number cover the cell? If so, add to list of valid numbers. And then that's really the algorithm. Now, the problem with this is you've got to go through. So the time complexity, I guess, is symbols times, and then all the cells around them, which would be 1, 2, 3, 4, 5, 6, 7, 8. 8 times numbers. And it's quite a lot. I mean, it's manageable. Like a computer's not going to have any problem with it. It's just one of those things. If you introduce them into your part one, you may get slightly messed up in part two. Then again, if you have a complicated part one, you can get messed up in part two as well. Anyway, let's explore a more efficient way. So let's say when we're extracting the numbers, is that how you spell symbols? It suddenly looks wrong. Anyway, extract the numbers, populate a set of number. No, wait. Can't be a set because then we would not have a root to find. Yeah, populate a dict of cell to number. At this point, we can check is the dictionary, does the dictionary have an entry for the cell? And then if it does, we can get straight to the number and we can add that to our list of part numbers. And we also need to make sure we don't duplicate any. So add to the set of part numbers rather than the list, because sets will avoid having any duplication in them. At which point we have, well, the complexity of a set in Python, I don't know, but it's, or a dictionary rather, same deal though, but it's going to be something on the order of 01, I would hope, for access. So then we end up with symbols times 8 times 1, essentially. So I think, yeah, I mean, there's other complexity here to do with, not like a big complexity head, but it's, it's going to be smaller anyway. Okay. Well, it feels worth doing. It's not too difficult, and it does make this algorithm a bit easier anyway. So we should be okay with that. In which case, let's think about our state. So our state is going to have probably don't want to call them numbers. Let's call them, what are they called here? Grid numbers. And we want to have symbols, grid symbols for completeness. We want to have valid part numbers, which will be a set of and then we want to have our coverage. or it's like cells to numbers, which is going to be a dict of, let's go coord to grid number. I think we can probably get away without doing any visualization here, but we might need to add that if we get into trouble. So I'll just have a sort of viz method here, just in case I need it. Just in case I get into any debugging problems. If I do, I need to jump to that viz pretty quickly so I can visualize out what's going on. Okay. We've got a couple other objects you care about as well. We've got coord, which is going to be x and y, and it's going to have a, well, in fact, that's oh, probably we should have like adjacents. Probably put this in my utility library actually, because it's a repeated thing I have to do. So I want to do that. And then we're going to have a grid number, which is going to be a coord. So this would be int. And then for the grid number, we're going to have let's have this. It's not going to really be a derived property, is it? Because the length of an int is hard to calculate. So I'll probably actually have this be width, and then the number can be an integer. Just hesitate around using any weird reserved words, but let's just go with it. And then we want to have a grid symbol. We're just going to have a coord again. It's going to have a symbol being a string. Great. And then we're going to, I think let's add a couple methods as well where we need them. So we have this viz. We want to have a sum part numbers, because that is what we're doing, right? Sum of the part numbers. Yep. Okay. Sum part numbers. We've got, does the number cover the cell? Our dictionary is going to do that for us. Where is it? We're going to need to have a method in here, I think, which should be covers cells, which is it's probably like get cells covering, which is going to get us a set, let's say, of coords it should be going through each. No, wait. Let me adjust this algorithm here. For each adjacent cell, if there is a number in the, if coverage has this cell add associated number to part numbers. Okay, so we need to get to populate this. We need to go. We need to get the cells that are covering the grid number, add them to the. Probably this can be a probably this can be a list. Add them to the dictionary mapped to the grid number. Yeah, so we're gonna yeah, fine. So I think we've got all the state we need. Just starting to think ahead to the methods now. Are there any other methods we need? Can we extract the numbers yet? No. So we need a parse line. We need to compute, obviously, we need a parse line. We need, and that's going to need to then call on it's going to need to extract the numbers, which will be fine. It's going to need to populate the dictionary, and it's going to do that by calling get cells covering on the grid numbers that we've got. Then it's going to extract the symbols. It's going to add them to the symbol list. Then we're going to go through each symbol and compute each adjacent cell for the symbol, which we can do with adjacents. We can probably have a no, we don't need that. We can get the coverage, add associated. Okay, fine. Let's go with having a get. God, why is it doing this? Get add numbers. Put this on here. Okay. Looks fine. All right, and plan of action. So make code, make grid number, make grid symbol, make state, and then I want to jump straight to, because I did the parsing badly last time. So let's go, well, actually, does that affect this time? No, it does not. That is another correction. Is this going to be difficult to parse? Somewhat. So let's go with parse line compute, and then I will have my grid set up. I'll have my state set up, and I can start implementing from adjacent, get cells covering. No, in fact, it doesn't really matter. Get cells covering. Then I can jump to parsing. Then that, and some part numbers. Then we win. Okay. This seems fine. Okay, let's go with that. It's quite a lot of work to do. Let's populate my files. Okay, let's start this going. Okay, my plan up, move this around, get myself comfortable. I've also upgraded to Python 3.12, so that should be good. Great. Let's go. Don't know why my editor's so verbose in everything it's showing me now. How that is, if I type into, I can't remember now. All right. I'm gonna fail the, that's annoying. Okay, I'm gonna just ignore that problem. And okay, figure that out. Actually, I want to research that later, how you do that. Okay, data class. And here we've got chord, symbol, string. Fine. Okay, and then Okay, great. Now let's work on adjacents. Should be a list of chord actually it can be a set, I think. Set will be easier. Don't have to worry about order. Okay, not hashable. This needs to be hashable, I'll tell you that. Are you sure it should be hashable? What's wrong with that? Is it that it needs to be frozen? Yes. Okay. Ah, okay. I'm missing some messed up some setup. Let me get rid of that. Get rid of all this. Don't need that. Okay, great. Anyway, wasted some time there. Okay. So this, if we're talking about 1, 1, then we've got 0, 0 up here, 0, 1. It will be to the left. So actually, let's go with 1. Let's go with 0. And then, okay, so 1, 1, 0, 0, 1, no, 0, 1, 0, 2, 0, 2, 1, 2, 2, 2, 2, 1, 2. No, wait. 1 is Y, right? 2, 2 on the. I'm getting myself confused trying to figure it out here. Let me calculate it and then figure it out. Easier to calculate. Okay. Okay, so that's top left. If it's the same, it's not that. Then that. Then 1 to the right, but the same Y. Then going down, we add 1 to the Y. Then going left, we take one away from the X, going left again, going up, and then we end up in the same place. Okay, fine. So what is this really? So I'm pretty sure this is the right one. Let's go with that. Let's hope that's right. Okay, let me just triple check it. 0, 1. Do we have 0, 0 in here? Yes, we do. Do we have 2, 2 in here? Yes, we do. Okay, that looks good. Great. All right. Voices into I really should add that to my library. Okay, back to the plan. Adjacents get cells covering. So for this, we want to go from for X in range coord. Let's use H range for this. Actually, this should help. H range from coord X to coord X plus width, and it should be width long. Always forgetting the self. Never lose yourself. Golden rule of Python. Okay. And then we want to, well, in fact, we can use a what are these here, right? We can use an what are they called? Can't remember now. Okay, chord. Okay, X is first. X self Y. For X in right. Okay, so now if we have a grid, my grid number is chord 1, 1, and the width is 3, and the number is 1, 2, 3, then my number get cells covering should equal 1, chord 1, 2, chord 1, 3. Ha, yes, H range saves me. H range is designed to prevent me from making 1 by 1 errors. Okay, 1, 4 should be 3. Okay, so I need to subtract 1 from that. Okay, expecting 1, 1, 1, 2. Huh. Why is Y changing? X should be first, right? Oh, well, yes, it should. That's my fault. In the tests. Okay, great. Now we're good. How are we getting on? Okay, we're looking at a gold run today. Grid symbol. Don't need to do anything. Okay, get cells covering we've got. Now parse line. Let's go with this. Go with this line. We run this. My state grid numbers should equal toward 0, 1, 2, 3, 4, 5, 6, 7. 7x. Oh, last line needs to take. What does it need to take? state line index. State. So let's call this y. Let's go with 5. So this should be 7, 5, in which case we should also be getting, what's the grid number? Chord width should be 2, and the number should be 58. And the grid symbols should be 7 and no, 5 and 5. And the symbol should be plus. Great. Okay, so great. Okay, so hmm, okay, fine. Just trying to work out how to get the index. Okay. Chord is going to be match start and the y. The width is going to be the group len. And this is going to be the int of that. Mm, that's good. Goodness. Ugh, what is it called? Silly syntax here. Okay, let's try. Okay, Python. All right, that worked. Let's try this. If we do that, we should have a. No, in fact, don't have time for that. Okay, state grid symbols, symbol matches. What is wrong with my syntax here? There. And it's state grid symbols. Okay, we good? All right, this should fail. And it does. This should fail. And it does. Okay, great. Gosh, slow today. Okay. All right, def calculate. Fine. Okay. Okay, it's not obviously failing. All right, now get valid part numbers. For this, oh, we haven't populated this either. Okay, fine. All right. State cells to. All right, so state. Okay. Oops. State. Cells to grid numbers. Board grid number. Okay, that's that done. 59. Fine. Okay, for symbol in grid symbols, symbol called adjacents. How do you check if that has? Yeah. Okay, if board in that, then self-valid part numbers and and then to sum these up, number. Okay. Four, three. Ah, it's wrong. Okay, that's not good. 4, 5, 3, 3. It's wrong, it's wrong, it's wrong. Okay, there goes my run, I suppose. Right, time to viz. What's the width here? 10. Y in, yeah. All right, and then okay, that seems right. So that's fine, fine, okay. Huh? So that's why. Okay. 633 is valid. 467 is valid. 598 is valid. 592 is valid. 35 is valid. 664 is valid. 755 is valid. 617 is valid. That should be right. But I'm missing one, I guess. Okay, 114 is not valid and 58 are not valid. 35 is okay. So we got 467 we do. 114 we don't. 35 we do. 633 we do. 617 we do. 58 we don't. 592 we do. 755 we do. 664 we do. 598 we do. So the result is wrong for some other reason, even though I've got all the right numbers. Is it the sum? Surely not. Ah, I summed them all up. Ah, gutting. Such a silly mistake. Okay, all right. Let's try with the input. Okay. And this show is now no longer valid either. Anyway, it doesn't matter. This one, let's copy it and find out if that is right. And it is. Okay, well, silver. Yeah, about 36 minutes. Fine. Okay, let's take a look at part two. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. Something goes wrong. Look out the window, holding a phone in one hand. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any asterisk symbol that is adjacent to exactly two part numbers. Its gear ratio is the result of multiplying those two numbers together. This time, you need to find the gear ratio of every gear and add them all up so the engineer can figure out which gear needs to be replaced. Consider the engine schematic again. In this schematic, there are two gears, this one and this one. The first is in the top left. Oh no, wait. It has part numbers 4, 6, 7, and 35. So its gear ratio is this. The second gear is in the lower right, adjacent to these two. Adding up all the gear ratios produces. Okay, so fine. So we're going to get the symbols that are asterisks, find all the ones that are then adjacent to two numbers, and then multiply those two numbers together. Then add all of those multiplications up. Now, the big question now for me is this gonna work with my code that I've got at the moment? So I'm able to determine where's my core item? Okay, here. Go over the adjacents. If the coordinate is in the coverage, then yeah, okay. So we should be good then. Yeah, so we go through the asterisks. Instead of just saying if and adding, we append the numbers that we get to a list. If that list is two items large, then we multiply the numbers together and we add that result to our result, right? So that in principle, that's quite possible. Do we need to diagram this out? I'm gonna make a plan and think it through because I did make this mistake before. Okay, so plan. Add new method get gears. Get gears should all get all star symbols, determine adjacent numbers. If there's two, add to the list of gears some add gear ratio to. No, we don't need to. No, actually, determine situation if they're let's say, okay, determine adjacent numbers. If there are two, multiply numbers together and to sum. Okay, well, yeah, fine. Do I have all the state in the right place for this? If I put it on state, I should be okay. Yeah, all right, let's go with this. Okay, copy part one into part two. Stop this wrong again. Reset the timer. Right, let's get rid of that. And don't need to be visualizing anything anymore. Okay. Calculate gear ratios. I'm gonna get like a list of integers out of this. Which we can sum at the end. Okay, so we want to get okay. Then we want to go through them. and that. And then if, no, actually we want to get them all. If the length of the adjacent numbers equals 2, it'll be a list of grid numbers. So it'll be number here, and then that will get our grid ratio. So let's return the sum of state. Well, that doesn't look that good. Okay. So those are correct. Okay, well, that's, we get me in here. No, we never are. Ah, it should be a set. Okay, great. And then we got to add, we got to just get them out, right? Do we have a product? What does this do? Okay. Trying to be too clever here. Okay. Is that the right number? Yes, it is. Okay, great. And that's the right one for, well, I hope it's the right one. And it is. Okay, perfect. All right. Learnings from today. I mean, I'm sure there's probably a simpler way to do this, but I don't feel terrible about this solution. I do feel a bit silly about not checking, doing all this visualization stuff without just checking for any silly mistakes in the output. I should probably work backwards from the output, from the incorrect output to the, backwards to, I just sort of suspected, I didn't have faith that I would get the grid stuff right. So I was just immediately like, it's probably that. Just, it's probably not a bad heuristic. It's just didn't work out this time. Could have got a gold there, but didn't. Other than that, probably okay. Be curious to see how other people have solved this one. Need to let's add that to my tools library. Okay, cool. See you tomorrow.